Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We started a discussion with the geometrical chapter, that is our second conic section, ellipse. What did we learn in that? We started what is the standard derivation of standard form of ellipse, right? Fine. What did you learn in that? We started with how do we assume what is focus, vertices, directrices, right? Then we derive the points of focus, then the equation of directrices. Fine. Okay. Other than that, you should also know what is lattice, rectum, focal chord and all those things, right? In the session, we'll just discuss about all those in the form of problems. We are not going to discuss any theoretical concept with respect to ellipse, because almost everything is similar to parabola. Is it okay? Fine. Shall we start doing the problems? Let's see here. Look at the first question here. He gave, find the equation of the ellipse with the focus at a particular point, E equal to given and directrix is given, right? So, how do we do it? If this is our ellipse, okay, and this is our directrix, isn't it? He gave focus, he gave directrix, and he also gave eccentricity, right? What is the definition for eccentricity? Eccentricity is nothing but SP by PM. From this, can I write SP is equal to E into PM, right? And what is S here? S is 1 comma minus 1, eccentricity is given and this equation is given. Can I assume a point and find the equation? Yes, right. So, let the point on the ellipse be P, then SP by PM is equal to 1. What is SP? The distance between focus and the point. What is PM? The perpendicular distance of a point to the directrix. Is it okay? Fine. So, let us substitute and simplify it. What is SP? SP is point, focus ka point and the point on the ellipse ka distance, that is under root x minus 1 whole square plus y plus 1 whole square is equal to, what is E? 2 by 3 into perpendicular distance from this point to this equation. What is it? X plus y plus 2 by under root 1 square plus 1 square. Is it okay? So, since both are square roots here, let me square on both sides. So, what do we get? X minus 1 whole square plus y plus 1 whole square is equal to 4 by 9 into x plus y plus 2 whole square by 2. Why? Here we will get root 2. So, root 2 ka square is 2. Is it okay? Now, let us simplify this. What do we get? X square plus 1 minus 2x, y square plus 1 plus 2y, 2 1s are 2 2s are here, 2 by 9 into x square plus y square plus 4 plus 2xy plus 4y plus 4x. Isn't it? A plus b plus a whole square? A square plus b square plus c square plus 2ab plus 2bc plus 2ca, right? Next, let me multiply this 9 that side, or else okay, directly multiply the 9, 1 and 1 will get cancelled here, okay. Now check, sorry, both are plus 1 only, right? We can't cancel it. So, let us multiply this 9 here. 9x square plus 9y square minus 18x plus 18y. 1 plus 1 is 2, 2 9s is 18, and here 2x square plus 2y square plus 2 2s are 4xy plus 4 2s are 8y plus 8x plus 8, 4 2s are. Is it right? Check once again, don't get confused here. 9x square plus 9y square, everything is fine. Is it okay? So, let us bring all the terms to one side. So, what do we get here? 9 minus 2 is 7x square, 9y minus square is 7y square, minus 18x minus 8y. How much is it? Minus 26x, then x 18 minus 8 is 10y, 18 minus 8 is 10. This is the standard equation of ellipse, isn't it? Is it okay, right? The main thing is you have to know what is the condition here. For ellipse, ellipse or hyperbola or parabola, remember SP by PM equal to E. But for parabola, since E is 1, we will not consider this heavily. But when it comes to ellipse and hyperbola, we are going to consider only this term, right? The term is also given as 2 by 3. Obviously, it is less than 1. Is it right? Fine. Look at the next question here. What is given? Find the standard equation of ellipse whose distance between the foci is 2, okay, and the length of lattice rectum is 15 by 2. Just remember one formula from this problem. Distance between foci, is 2AE, okay, that is given as 2, remember. Fine. Next, when it comes to length of lattice rectum is 2b square by a, which is given as 15 by 2. Is it okay? So, let us simplify or divide or do something else in order to find the values of a square and b square. Okay. What is b square from the last theorem? I mean the standard derivation, what did you remember? B square is nothing but a square into 1 minus e square, right? So, b square is a square into 1 minus e square. From this, let us write it as a square minus a square e square. Is it? What is a here? A is 1. So, let us substitute it here. A square minus 2 will get cancelled, I will get it as 1. This is my b square. So, let me substitute in this. What do I get? 2 into a square minus 1 by a is equal to 15 by 2. Cross multiply, 4a square minus 4 is equal to 15a. 4a square minus 4 is equal to 15a. 4a square minus 15a minus 4 is equal to 0. 4 4s are 16. So, like we can factorize it. We will get it as 4, let me write it here only. 4a square minus 16a plus a minus 4 is equal to 0, right. If I take 4a, I will get it as a minus 4. If I take it as 1, I will get it as a minus 4. From this, a minus 4 into 4a plus 1. So, the value of a will be either 4 or minus 1 by 4. Since it is the distance or length, it cannot be equal to negative. So, obviously, the value of a is 4. From that, we will get b as 4 square minus 1, that is 15. Now, what is the equation of ellipse? X square by a square plus y square by b square equal to 1, that is x square by 16 plus y square by 225 is equal to 1. This is the standard form of ellipse. Okay. What did we do here? First, they gave the distance between foci as 2, which is 2AE. Next, the length of lattice rectum, which is 2b square by a, they gave it as 15 by 2. You have to solve this both in such a way that we have to get the values of a and b. Is it clear? Shall we go on to the next problem? Let us do. Look at the next question here. He gave, find the equation of the ellipse whose distance between the foci is 8 and the distance between directrices is 32. What is distance between two foci? Which is nothing but 2AE. Okay. Distance between foci is 2A, which is given as 8. Similarly, distance between directrices is 2A by E, which is 32. Is it okay? So, we have to solve these two in such a way that we have to get the value of B, isn't it? So, first let us multiply these both. What happens? 2AE into 2A by E, is it? So, AE will get cancelled, right. Here 2 1s are 2 16s are 2 1s are 2 4s are, sorry, 2 1s are 2 8s are. So, obviously, I will get it as A into A equal to 8 into 8. So I will get the value of A as 8. Is it right? Fine. Similarly, let us divide these both. So what do we get? If I divide 2AE by 2A by E, I will get it as 8 by 32, which is 2 will get cancelled. 8 ones are 8 fours are. Obviously, I will get E square is equal to 1 by 4. E is 1 by 2. Is it? So, can I find B from this? Yes, obviously. So, what is B? B square is A square into 1 minus E square, which is, what is A square? 64 into 1 minus 1 by 4, which is 64 into 1 minus quarter, that is 3 by 4, 4 ones are 4, 16s are, therefore 16 threes are is 48, B square itself is 48. So, let us directly substitute in the standard form. What is it? Equation of ellipse is x square by A square plus y square by B square equal to 1. Obviously, x square by 64 plus y square by 48 is equal to 1. This is my equation of ellipse. Is it? Did you understand? So, let us move on to the next problem. Find the eccentricity of ellipse if the length of lattice rectum is equal to half of its major axis. What is the length of lattice rectum? The thing which we did in our recent problem. Length of lattice rectum is 2b square by A, right? And what about the length of major axis? Length of major axis is 2A. Let us assume A to be x axis to be the major axis. So, it is 2A. He is telling that length of lattice rectum is half of length of major axis. Okay. So, can I cancel 2 to right? So, I will get it as 2b square is equal to A square. Yes, but what do we know? B square is nothing but A square into 1 minus E square. So, let us substitute it there. So, 2 into B square is nothing but A square into 1 minus E square. So, A square will get cancelled. I will get it as 2 into 1 minus E square is equal to 1. From this, let me write 2 that side. 1 minus E square is 1 by 2. So, 1 minus 1 by 2 is E square, right? From that, I will get E square is equal to 1 minus half is half. Obviously, the value of eccentricity is 1 by root 2. Isn't it easy? They didn't even give a single constant here. They just told that the length of a lattice rectum is half of major axis. From that, we will get the eccentricity as 1 by root 2. Is it okay? Shall we move on to the next problem? Let's do. Look at the next question here. He is asking us to find the equation of ellipse if it passes through 2 points, right? We did this kind of question in circles and parabola also. How did we do? In circles, we used to have 3 points. Why? We have 3 parameters G, F, C, right? When it comes to parabola also, we used to have 3 points because the equation should be in the form of y equal to ax square plus bx plus c. Right. Here also we have 3 constants A, B, C, that is 3 parameters. Here also when it comes to a standard form of ellipse, how is it? X square by A square plus y square by B square equal to 1, right. So, we will have 2 parameters here. Standard equation is x square by A square plus y square by B square is equal to 1. Is it right? So, we have 2 parameters, we can have 2 points. So, that we will substitute both and we will find out the values of A square and B square. Is it? Now, see here, this equation 1 passes through minus 2 comma 2, right. So, let us substitute this minus 2 and 2 here. Minus 2 cos square by A square plus 2 cos square by B square equal to 1. So, what do we get here? 4 by A square plus 4 by B square equal to 1. Isn't it? Fine. Similarly, let us have this equation. Equation 1 passes through 3 comma minus 1, that is 3 square by a square plus minus 1 square by b square is equal to 1. Do not forget this. So, 9 by a square plus 1 by b square is equal to 1, isn't it? So, we can solve this kind of equation, right? So, let us subtract, you can do it in any form. Let us multiply 4 to this equation and simplify, or else let me write like this: 1 by a square plus 1 by b square is equal to 1 by 4. Let me take it as equation 2 and this as equation 1. Okay, can I write like this? So, let us subtract 2 and 1, that will be 9 by a square plus 1 by b square is equal to 1. 1 by a square plus 1 by b square is equal to 1 by 4. Let us subtract. 9 by a square minus 1 by a square, how much is it? 8 by a square. Here 1 minus 1 by 4, okay. 1 is nothing but it can be written as 4 by 4, right. Therefore, this will be 3 by 4. From this, we will have a square ka value as 32 by 3. Isn't it? 8 4s are 32 by 3. Is it okay? Similarly, let us find the value of b square. Okay, you can substitute it in any form, or else if you want to multiply this by 9, multiply this by 36 and subtraction is also fine, or else let us substitute it here in this form. Okay, from 2, what do we get? 1 by a square is 3 by 32. 3 by 32 plus 1 by b square is equal to 1 by 4. Let me write it as 1 by b square is equal to 1 by 4 minus 3 by 32. LCM is 32. In 4 table, when do we get 32? 8s are. So, 8 minus 3. I will get it as 5 by 32, which is b square is 32 by 5. Now, let us substitute a square and b square in 1. So, what do we get? X square by a square is 32 by 3 plus b square by 32 by 5 equal to 1. So, we can write it as, this is one form, or else 3x square by 32, 5y square, this is by 32, this is y. So, finally, 3x square plus 5y square is equal to 32. This is one more standard form of ellipse. We can write it in any form. Is it okay? These are the basic questions of ellipse. How do we solve it? How do we find it? Okay, how do we find the equation with a few basics, whether focus is given, directrix is given, there is a distance between two foci, distance between two directrices, or length of lattice rectum are given. Okay, fine. Till now we did how do we find the equation of ellipse. Now, if the equation of ellipse is given, we have to find out what is center, foci, directrix ka equation, everything. Okay, we did in parabola also this kind of question. Shall we see how do we find it? Let us see. See here, for an ellipse, we have to remember that it is always in the form of oval shape. It is similar to the double of parabola. So, there will have only one focus, here will have two foci, right. So, for the standard equation of ellipse, the center is origin, right. For this kind, the condition is A is greater than B, where A is this A dash 2A, okay, which is a major axis, and here this is the minor axis. Clear? So, the center is obviously origin, whereas the vertices are A comma 0 and minus A comma 0, right. And the foci is we derived, this is A comma 0 and here it is minus A comma 0. The time which we derived also I told, this is not just A comma 0, this is plus or minus A comma 0, right. Next, when it comes to eccentricity ka formula, you know that B square equal to A square into 1 minus E square, right. From that, if you simplify it, if you derive it and everything, you will get this eccentricity, isn't it? How do we get? Just see here, b square is equal to a square into 1 minus e square. Can I write 1 minus e square as b square minus a square? Yes. So, e square is 1 minus b square minus a square. If I take LCM, I will get it as a square minus b square by a square. This is e square. If I remove this square, this will be like a square minus b square by a square. This is a normal rule. There is no difficulty in defining it or something else. When it comes to directrices, we will have two directrices. This is x equal to plus or minus a by a, and this is x equal to minus a by e. So, the equation of directrices are x equal to plus or minus a by e. Yes. Next, the major axis is obviously x axis, which is y equal to 0. The minor axis, it is y axis, whose equation is x equal to 0. Yes. Fine. This is the equation of ellipse whose major axis is on x axis. What if the major axis is on y axis? Something like just I will draw it very small figure here. This one, okay, x y. What if major axis is on y axis? Simply just replace, okay. Just see here, x square by b square plus y square by a square equal to 1. How? Here a is less than b. Obviously, here the a, the length of this a is very less than this b. Okay, is it right? Or if I want to specify this condition, we can directly write as x square by a square plus y square by b square equal to 1. Is it right? If you do not want, you have to specify b square here, a square here, if you want to use this condition only. Is it okay? So, just remember, if a is less than b, this will be like this, ellipse is like this. If a is greater than b, ellipse is like this. Clear? Next, obviously the same center. What are the vertices here? This is 0 comma b and this is 0 comma minus b. Since it is on y axis, it will have only y coordinate. Next, foci. Here we will have s dash. Again, this will have only y coordinate 0 comma b, and here it is 0 comma minus b. When it comes to eccentricity derivation, here since a square is greater than b, we will have a square minus b square. Here since b is greater than a, we have to write it as b square minus a square by b square. Okay. Next, directrices, here it is x equal to a by e and here it is y equal to b by e, plus or minus b by e. Here the major axis is x axis, here the major axis is y axis, whose equation is x equal to 0, right. When it comes to minor axis, here it is y equal to 0. Is it right? These are the basic things we have to remember for any conic section. Even if it is in the parabola, we used to do these all kinds, right. Fine. Using this information, we will solve more problems. That is, when the equation is given, we have to reduce it into the standard form, then we will perform all those equations. Is it right? Fine. What all we learned in this session, we start with how do we form an equation of ellipse when the given conditions are there. That is the distance between two foci, directrix and all those, right. And we also learned how do we find all these parameters when the equation of ellipse is given. Clear? Fine. Let us do the problems based on this in our next session. Okay. Fine. This is for today. Let us meet in the next session with the more problems of ellipse. Thank you.